Well, welcome back, everyone. We have the famous Lindsey here from Johnny Appleseed. She's a naturalist, and as you see in front of us, we are going to be discussing the egg, and I am ecstatic about this.
That is excellent, Chris. Well, I've got some neat egg things to share with the folks at home today, and this is a small but mighty object, the incredible egg. So in animals that use eggs for their growth and development, the female is producing this little self-contained unit. It has part of the genetic material and all of the nutrients that a developing embryo will need. And each species produces an egg that is uniquely adapted to their evolutionary history, their physiology, their habitat. So the eggs of birds, reptiles, and amphibians are all going to be different. But we can use the common chicken egg as a way to explore the world of eggs. And we need to start on the outside. So we're going to investigate the shell, and we're going to break down one egg and build up another to kind of show folks what's inside. So this shell on the outside, a thin protective layer, it's made of calcium carbonate, which is actually the same ingredient as limestone, the same mineral composition. So it's fairly resistant to mechanical force, but as we'll see in a moment, it can be broken down by chemical means. And I've got our shell here that we're going to build.
Okay.
So on the inside of that eggshell, we'll see in a moment, there are two membranes. We have an inner membrane and an outer membrane. The outer one helps to provide a little bit of reinforcement to the shell. It's adhered directly to the underside. And then the inner one is going to contain all of the things in the middle of the egg. And right between, you'll notice that there's an airspace. And if you've ever hard-boiled an egg and cracked it before, you know at the bottom there's an airspace there. And that provides the air for the developing chick. Now, when we crack open the egg, if you'll do so for me on that plate, we'll see that there you go, that's an egg dissection right there.
That was a mutilation.
We'll see that there's a clear liquid that flows out of that. That is the egg white, or the albumin. When we cook eggs, that turns white. All the protein in there is being denatured, but the actual composition is about 90% water. So the albumin is providing fluid or liquid for the developing chick. And of course, we know this conspicuous structure in the middle, what's that?
That's the yolk.
That's the yolk. The yolk sac is providing the nutrients for the chick. So it's the fat, the protein, the carbohydrate, and other micronutrients for them. And that's the only source of food that they're going to have while they're in the egg. And I love this one because on our egg, you'll notice these kind of white band, stringy, mucus-looking structure. These are these rope-like structures here. These are the chalazae. What helps suspend the yolk inside the egg. So it's not floating around freely. It's going to be kind of contained. And on the surface of the yolk, I'll slip my chalazae underneath there. On the surface of the yolk, sometimes we can see a small white or gray spot. It's called the germinal disc. I've got a little pom-pom here to represent that. And that's where the hen is putting her half of the genetic information for a chick eventually. Now, I said there before that the shell is very resistant to mechanical forces. However, chemically, it can be broken down. And I have a variety of naked eggs with me here today where I've dissolved the shell just with some simple vinegar. So you can place your eggshell in vinegar for about 24 hours. We'll get an egg that looks like this. So the calcium carbonate is being eaten away by the acetic acid in the vinegar, and the shell is literally peeling off. There is some carbon dioxide bubbles that are forming on the surface, and if you run your finger across it, it's rubbery. It's being contained again, remember those membranes, but that calcium carbonate shell is flaking off there. And the longer that you let it dissolve in there, you can see the clear side of the membranes there. The longer that you let it dissolve in there, a little bit kind of stronger and bouncier, it becomes almost like a rubber egg. I have one here in our pink tray, which has been working for 96 hours, 4 days. And I'd like to see if you could bounce that egg, because this is an easy experiment that you can do at home. Well, start small and we'll see how high. So when you do this with kiddos, start small, Chris.
Okay.
And see, there we go. Right, so you can do this with kiddos at home.
Will it explode?
It will explode, but that's the experiment. We're going to see how high we can get it to go. Oh, that was a quick experiment there. You can also place your naked eggs in a variety of different materials to see what happens to the fluid on each side. So I've got a control egg just in the white vinegar. You can place it in a solution of corn syrup and see that the egg will shrivel through the membranes, the water's being pulled out. Or you can put it in something like distilled water and notice that it expands because the water is rushing in. And those selectively permeable membranes helping provide a little bit more strength.
Well, I didn't know it was going to explode.
Science of eggs.
You said it would bounce, but it did bounce. But
only so far.
all right. Well, Lindsey, thank you so much for showing this excellent,
It's exciting.
It's so exciting. It is exciting learning all about the eggs. All right. Well, thank you once again.
Thank you, Chris.
All right. Well, don't go away because we have more when we return.